Hello everyone, Sajjad here. Welcome back to the Free Science Channel Python programming lecture series. In this video, I'm going to teach second part of object-oriented programming. I'm going to turn off the camera and start teaching. First, let's review what we have learned in the previous video. In the previous video, we learned the general structure of the customized object in Python. We start by writing a class and name, column in front. And also we said we write functions inside the class and we call them method. And we had for the first method, init method, if you remember, we had dunder init. By dunder, I mean underscore, and self. The parameter self inside the init was very important, and passing some commands inside the function. And also we can write more functions depending on what we like the object do for us. For example, function A, and column in front, and self inside, and other comments. And if you remember, we said init instantiate the object right when it is created. It means that when you run the class and assign the instances of this class to a new parameter, this line will be executed automatically, and we do not need to call it for execution. If you remember from previous video, we had a class. His name was cat, and we said cat has some properties like has a color, has an age, has a name, and we call these properties, we called in the object-oriented programming, we call them attribute. And also cat can perform some saying, for example, can jump, can make a sound, and we call them the method. Also, we learned that there are the Python itself has many inbuilt objects like init, like string, functions, list, and so on. In this video, first, I would like to show an image to you and make our class about this image. Suppose that you have an airplane. This airplane can move along x-axis, y, and z-axis. You see the Cartesian system here. For conserving the time, we suppose that the airplane just can move along x and can move up and down along z-axis. This airplane has a name. For example, it's Airbus, it's Boeing, and has a color, has a weight. These properties are called attributes, and this airplane can take off and land and move forward, backward, rotate, perform other actions, and which called these actions are called method. Let us start to write our class. We select a name for our class and we call it airplane, and put a bracket in front. First method is dunder init, and self inside the bracket. The attributes of this airplane, as we said, we have self name equals to name, but name should be assigned inside the bracket also. Name, color, weight, speed, and self, color equals to color, self dot weight equals to weight, self dot speed equals to speed. Name, color, weight, and speed should be assigned to the our object. And this airplane has a position. For example, it has self X location. Initially, we consider location 0. It means that the airplane placed in the origin of the Cartesian system, self Z log equals to 0. And we are not going to add the location of Y to conserve the time. Also, the airplane needs the fuel to move. Self gasoline initially equals to 0. Okay, now let's start another function. Another function, if you want to move the airplane along x-axis, we'll have self x length, and then we will write self x log will be updated by adding the x length to the previous value of x log. And for moving along z-axis, let's say up, for going up, we call it upward. Going up, self z length, and it should be updated, the column from self z log plus equals to z length. And another method for move down, we will have another self and another z length. You close the bracket column. And because the airplane, if it goes down, cannot go under the ground, we should consider an if condition to make a real example. For example, you would say our z log will be updated like this, but a negative here. Then we will check the value of the z log. If self z log was minus less than 0, then we'll fix the value of z log to 0. Okay, everything looks fine. Now I'm going to run the class. There is no error, and I define airplane 1 and assign all instances of airplane class to A1, but we'll get an error because we have 1, 2, 3, 4 items which should be defined. These attributes should be given, and the name, let's say, name is Boeing. The color, because there are characters, it will be written inside the quotations, and the weight, for example, is 1,000 kilograms, and the speed is 800 kilometers per hour. Okay, now we run it, it's fine. There is no error. And now we want to check, for example, what is the X location of airplane? It is in 0. And what is the Z location? It is 0. And for example, if we want to know how much gasoline we have, it is 0. We can print out all of these attributes. For example, say A1 x log a1 dot z log and a1 gasoline or a1 the colorlet. Yeah. We see that it is at 0, 0, and the color is white. Also, we can add name and other attributes. Now, I would like to move the airplane along x-axis a bit. Therefore, I should use this method, move along x, a1 dot move along x, 10 kilometers. And we'll have, if you print the location of the airplane, we'll see x along x, the airplane moved 10 kilometers forward. If you want to move the airplane along z-axis, we can, let's say, move upward, a1 dot move up, and let's say 5 kilometers. What's the problem? A1 is not defined. It should be A1, not A. And by printing out, we see, yeah, now the airplane is at 10, 5. 10 is the X coordination, 5 is the Z coordination, 5 kilometers above the ground, and the color is white. I would like to make our examples about a bit practical and real. For example, now there is no gasoline inside in the airplane. How the airplane can move. So let's define a function, a method, and call it charge gasoline, and self. In each charging, our airplane can get, let's say, self gasoline about 400 liters. I'll write a comment here to not get confused. Gasoline, and at each time that airplane receives the gasoline, gets 400 liters. Now, the amount of the gasoline, I would like to add it. See how much gasoline we have. Airplane A1 dot gasoline, it's 0. Let's charge our airplane a bit. Let's charge a bit fuel. A1 and gasoline. Airplane object has no attribute charge gasoline because I have not executed the class. Didn't recognize charge gasoline. Let's run everything from beginning. Yeah. Now, if you print out, we will see that we have 400 gasoline. Okay. Now I would like to make our example a bit practical, more practical, and make a relation between the movement of the airplane and consumption of the fuel. First of all, we should define something in init function and define, for example, a self fuel consumption. Oops, I should use underscore fuel consumption rate and put it equals to, let's say, 5 liter per each kilometer. Self dot fuel underscore consumption rate. It is rate of the fuel consumption from our airplane. And when airplane moves along X, we should define that how much, first we should check how much fuel we require. Required, we can say required fuel equals to this value that we define here, time X length. And it shows how much fuel we require, and we should check how much fuel we have. If, for example, self-gasoline, if self-gasoline is larger than required fuel here, then we can move. Then we have permission to move forward, and then we should be careful about the indents. We can update the X location, and also we should update the amount of the fuel for our airplane. So gasoline equals to required fuel. The amount of required fuel should be reduced from total amount of the gasoline. Okay, if the self-gasoline was larger than required fuel, we'll update X and we'll update the amount of the gasoline. If not, else we should get an alarm that saying to the pilot that alarm, there is not enough fuel. Okay, and for X, movement along X, we did these changes. We need the same modification for the movement along Z, but it should be Z lengths. And the same if condition and the same else. It should be like, yeah, if gasoline was larger than the amount of the required fuel, the Z lock should be updated because it goes upward, and the amount of the gasoline should be modified like this. And for downward, again, the same if condition, we need to check the amount of the fuel first. If it was okay, if it was larger, then we should write, we should update the amount of the Z lock and the amount of the gasoline. And then if the Z lock was negative, yeah. Otherwise, by one else, we can give an alarm to the pilot, yeah, we need fuel. Let's run this class. So Z lock equals to 0. The reason of this error, I think, is we need an indent here. Let's write everything from beginning and see if we have any error or not. Yeah. So we have airplane A. The name is Boeing, color is white, weight is 1,000 kilograms, and 800 is speed, kilometers per hour. The location is 00 and color is white, let's use gasoline instead of, yeah, it is at 0, 0, and the amount of the gasoline is 0. If we move we use move along X 10 kilometers, we want to move the airplane 10 kilometers along X, we get an alarm. And if we move it the same amount or more or less than 10 along Z, we should get the same error because the amount of the fuel is 0. What we need fuel. So let's charge our airplane and do not forget the bracket. Now for moving 10 kilometers along Z, yeah, if the airplane can move, and now we want to know where is the airplane. The airplane is at 0, X coordination is 0, Z is 10, and the amount of the fuel is 350. Let's move the airplane 100 kilometers and see, because our rate is 5 per kilometers. If you move it 100 kilometers, what we expect? If you move it 100 kilometers, because 100 will be multiplied by 5, we need 500 liters fuel, but we have totally 400. Therefore, we need to charge the airplane again. But let's move, change the 100 to, for example, 50. Let's move it 50 kilometers and say the remaining amount of the fuel now is 100, and we are at the, we moved 50, and before it moved 10, 50 plus 10 becomes 60, and remaining amount of the fuel is 100. Let's move downward a bit, and we want to move 10 kilometers down, and we moved it. Now we want to print out the stages of the airplane. Yeah. 60 minus 10 becomes 50. Now we are at the Z coordination is 50, and the remaining fuel is 50. We can use the remaining amount of the fuel for moving along X axis, along X, and put it, for example, 5, and print out the stages of the airplane. Yeah, the remaining amount of the fuel is 25. Z coordination is 50, X coordination is 5. And yeah, you see, in this example, we had the same structure as I showed you in the first template. It is a class, name, and body of the object of the class. And we have different functions. Because these functions are inside the class, we call them method. By this method, we define an operation that we want our class performing. At the first step, we define the attributes of our class, like weight, name, or speed. And then the functions, the operations functions that we wanted the airplane do are defined in move along X, move up, and move down. And you saw that by moving along X and Z got updated. and the amount of the gasoline also, according to the predefined rate, got updated. And also, if we had not enough fuel to move, we got an alarm.